All right, so let's go through this part 2 real quickly here. Another example that we have here is, it says find the probability of 3 dependent events. So this is pretty much the same as what we've been doing. It says your teacher passes around a box with 10 red pencils, 8 pink pencils, and 13 green pencils. If you and 2 people in your group are the first to randomly select a pencil, what is the probability that all 3 of you select pink pencils? Well, again, because there's 3 separate events, we look at it like this. This is going to be the probability of A times the probability of B times the probability of C. Except the difference is, and we want to fix this real quick, so they are 3 separate events, but they are dependent on each other. So we're going to fix these real quick. So, you can still write it like that, and as long as you understand the concept, it's not a big deal, but really it's the probability of B if A happened, conditionally that A happened, and then the probability of C, conditionally that A and B happened. Okay, so we can't really finish the problem if the first things don't happen because it ruins it. So what we're looking at here is the probability of A is we want a pink pencil. So therefore, it's going to be 8 is the total number there out of 31 total. And then our second one, assuming the first one happened, we now only have 7 pink pencils left, and we actually only have a total of 30 left. And then the last one, if again the first 2 happen, then we only have 6 left, and now we only have 29 total. So what you do is you multiply those 3 fractions together to get a grand total of 336 over 26,970. And that will give us a decimal of 0.012. So the chances of that happening are actually not that great. Okay? So again, it's all the same. You don't have to write these out every single time, but it's to let you know when you understand that the first event happened, then we can make adjustments in the second event. Because if the first thing didn't happen, then that screws up our second one and our third event. So we need to make sure that we are understanding if the first event happened, then this is how the problem changes. Okay, so what I want you to do is try these next 3 checkpoints on your own and hit play when you're ready, and then we're going to be done. All right, so in the first one, we're using example 3, which is on the other side of this paper, and because we're only dealing with females, it tells us that we're dealing with females. So now it's a conditional probability, so now our total number changes to 100. And because there's 41 females with hazel eyes, it's 41 over 100, so we get 0.41. The second one, dealing with the marbles again, what's going to happen here is we are taking yellow marbles, and then we're taking yellow marbles again, but we're replacing it. So it's just 15 over 37 times 15 over 37. That's an independent type event because they're both independent of each other. Multiply them together, we get 0.164. And then the second one is if we don't replace it, then understand, we have 15 out of 37 the first time, same thing, but then we subtract 1 from our yellow, and we subtract 1 from our total, and that gives us 0.158. And then in the last one, pretty much the same as example 5, but we're dealing with the red pencils. So we had 10 red pencils to start out of 31 total. Second one would be 9 because we took 1 out of 30, and then 8 because we took another one out of now 29. We get an answer of 0.027. So I hope this makes sense. I hope it's pretty clear. This homework here is subject to change, but just come with questions tomorrow. Don't forget to take your quiz on Edmodo, and I will see you then.